Okay. Hi. I thought it'd be a little easier just to make it as a video. Um, I can see your confusion, but what I've actually got here is two different questions, right? One is find the derivative of this one, and the other one is find the derivative of this one. So you can see I split it here, right? So this is all of this one, and I'm going to write this all again, but just so you know, that's all of this one, and then this one over here does a strange path. Um, I set it up here, then I go to there, and I come all the way down, and that's my final answer. Um, so, and then I actually went and did it again down here using the quotient rule. Okay, so that's the little confusion with the way the notes just showed up. But here, let me show you these problems real quick. And there's a couple of things going on here. Um, one is this is a product. It's a product of two functions. So I'm looking to use the product rule. Which I'm just going to write this way. So you have two functions being multiplied together. You want to find the derivative. It's the first derivative of the first times the second plus the derivative of the second times the first. Okay, so what I'm going to do is I'm going to identify, I'm going to call one of these A and the other one B. All right, so what I did over here was I let A be x squared and B is square root 2x plus 5. All right, so you can see from this formula, I'm going to need an A prime, which I got right here. And I'm going to need a B prime. Now that's going to involve the chain rule. So I know you were having a couple of questions with that a little bit earlier too. So let me just kind of explain this over here to the side. So I'm looking to find the derivative with respect to x of square root 2x plus 5. So I want to use the power rule onto this. So I'm going to write this out the long way, but then we can go back and you can see how we end up with the answers we end up. But I'm going to do it out the long way right now. So I'm going to change this into just a power rule, and I'm going to do it with a substitution. Yeah, so I'm going to let U be this thing in here in the middle. Right? So what I've got to find then, so I guess, well, here. So that means the square root of 2x plus 5, I'm just rewriting as the square root of u, right? U to the 1/2. So, and again, here's the chain rule comes into play. Here's how the chain rule works. If I'm taking the derivative with respect to x of u to the 1/2, well, these variables do not agree, right? Like they do here. So what I'm going to do is I'm going to write 1/2 u to the minus 1/2, the derivative of this whole thing. Then I do times du dx. And I do that because my variables don't agree. This is the chain rule. I'm going to show you that again. If I'm taking the derivative with respect to x of x squared, my variables agree, and I just write 2x. If I'm taking the derivative with respect to x of any other variable, I'll just say y squared. I do 2y, but then times dy dx for that chain rule where my variables don't agree. All right. So in this particular case, I have what u was. U was 2x plus 5. So I can see that du dx, the derivative of this thing with respect to x, is just 2. Right? So if I put all of this back in, I'm going to have 1/2 u, which was this, right? U is 2x plus 5. Times the derivative of the inside, 2. So that's how this always works, right? Is when you have some larger function in here that's being raised to a power, I'm going to use the chain rule, and this is my chain rule spot. Now I can just simplify this, the 2's cancel. So, I mean, again, so here I did it out the long way. Here's what's always happening. And maybe if you know, you'll still kind of like keep getting lost. Maybe write this out a few times and it'll start to be more obvious to you. But right, I tend to just say, and then multiply by the derivative of the inside. So I tend to just do this in one step, right? I knew that was 1/2. So I just do 1/2 2x plus 5 to the minus 1/2. And I just say, times the derivative of the inside, 2. Now, what happened was all of this business. But, we don't need to write this all out every single time. Okay, so now I've got my b prime. There it is. It's the derivative of this thing, which we said was this. And again, nothing particularly special about it being square root. If this had been 2x plus 5 cubed, I would have done the same thing. And now I'm going to do, to get my derivative, I know that f prime is going to be a prime b plus b prime a. So I'm just going to say that's 2x times the square root of 2x plus 5 plus x squared times 1 over the square root of 2x plus 5. Which is exactly what I had. Oh, sorry, just wait a second here. So I'll just combine that. There you go, with my little side figuring of how I actually figured out b prime for here. So if you look on my notes, that is what I have, right? So I said there's a, there's a prime. I said there's b, and I just figured out b prime. See how I did that in one step, right? Just 1/2 to the negative 1/2, and then times the derivative of that 2x plus 5, which just gave me 2. But then there's my f prime, a prime b plus a b prime. Now on this one, so we notice this is a quotient rule, right? And I guess all I was showing here is I can think of the quotient rule like a product rule. And I just did this all out, right, with the a and the a prime and the b and the b prime. And I just put everything together and did some stuff. But I was really getting at this point is how you should actually do it, which is you should use the quotient rule. A prime B minus B prime A over B squared. And you see, that's exactly what I did here. I listed my A, I listed my B, because I have A in the numerator, B in the denominator, and then just found all my business and put it in here. So this is really the actual way to do this problem down here. I guess I was just motivating where you're getting this quotient rule from by doing it out as a product. But it's not necessarily how you want to do it. If you want to look at anything, right, you want to look at this one and this one. All right. Hope that does help. But do let me know. Thanks for the questions.